Hello everyone. In this video we are going to talk about lubrication. When moving parts of any machine like bearings, most especially bearings and the other components in gearboxes, there is always need for lubrication. Now lubrication is the science of reduction of friction by application of a suitable substance called a lubricant between the rubbing surfaces of bodies having relative motion. The lubricants are classified into the following three categories. We have liquid lubricants like mineral or vegetable oils. There are semi-solid lubricants like grease. There is also a category of solid lubricants like graphite or molybdenum disulfide. Now the following are the objectives of why we do lubrication. Where we do lubrication, first of all, we want to reduce friction. Of course, when we have friction in a machine, we are going to, this friction reduces its efficiency. Therefore, we must reduce that particular friction to a minimal level. We also have to reduce or prevent wear. Yes, we do lubrication to carry away heat generated due to friction. Yes, these points are interrelated but very important. We also do lubrication to protect the journal and the bearing from corrosion. Okay, having understood the objectives of lubrication, let us look at some types of lubricants. We have grease. Grease is created by combining oil or mineral oil with thickeners such as lithium-based soaps. And this grease is also just put on moving parts of the machine. They could be pins, they could be bearings, and all those points where we feel that greasing is required. And this is always done through greasing nipples on some parts of machines. Let us also look at another type of lubricants like oils. These are thin liquids made up of long polymer chains with additional additives such as antioxidants, which prevent oil from oxidizing, and corrosion inhibitors, which prevent corrosion. In an oil, we have additives which are antioxidants. These prevent the oil from oxidation, and we also have corrosion inhibitors which prevent corrosion. There is another category of penetrating lubricant. Penetrating lubricants have low viscosity and are designed particularly for infiltrating small cracks on surfaces to increase lubrication and split up rust. Because usually you want to tighten some, to loosen some maybe nuts that have gotten stuck in pieces or in your work pieces, and therefore you don't have, maybe you have run out of options. So if you have run out of options, penetrating lubricants are one of the options you can run for that can help you to loosen the nut or the bolt that could be stuck in the workpiece. They are therefore used in removing stuck nuts. So those are penetrating lubricants. Another category of lubricants is called dry lubricants. Dry lubricants have certain elements such as silicon, molybdenum, and graphite, which have a very slippery molecular nature, which reduces friction in moving components such as threaded rods, locks, and hinges. These are particularly used in such components like threaded rods, locks, and hinges. So that is a dry lubricant. Now let us look at the properties of lubricants. The properties of lubricants: one, we have viscosity. and this is the measure of degree of fluidity of a liquid. It is a physical property by virtue of which an oil is able to form, retain, and resist shearing a buffer film under heat and pressure. In other words, this oil that you put with this kind of property called viscosity, it is able to form, retain, and actually give resistance to shearing a buffer film under heat and pressure. The greater the heat and pressure, the greater viscosity is required of a lubricant to prevent thinning and squeezing out of the film. So basically, this is viscosity is a property of one of the properties of lubricants. Number 2 is oiliness, which is the joint property of the lubricant and the bearing surfaces in contact. It is the measure of the lubricating surfaces under boundary conditions, where best metal to metal is prevented. Actually, you prevent base metal to metal only by absorbed film. There is no absolute measure of oiliness. Next is density, and this is a property that has no relation to lubricating value but is useful in changing kinetic viscosity to absolute viscosity. So density is a very important factor when we are characterizing lubricants, and therefore once you are to identify a lubricant, you must make sure that you consider also its density. We also have viscosity index as one of the factors or the properties of lubricants. The term viscosity index is used to denote the degree of variation of viscosity with temperature. Yes, that's why you find some fluids indicated 20 W and 50, others you find only maybe 50 W. So these figures, the 20 W it means that the viscosity of that oil or the lubricant is 20 in cold starting, or in winter. This W sometimes one can call it winter, but it is just basically for starting, cold starting, or starting of the engine at low temperatures. The 50 is the viscosity of the oil at higher temperatures. In other words, you will find that this particular component of viscosity index is very important, because we are saying it is denoting the degree of variation of viscosity with the temperature. It means this viscosity is changing at 20. We have a viscosity here, and viscosity of the we have viscosity of the oil at low conditions, and we have also viscosity of that particular oil at higher temperatures. So you find this particular oil, the 50 W is actually basically in countries maybe where you have high temperatures, but this one can be in countries where you have low temperatures. In other words, the viscosity of oil here is high. Therefore, it means in sometimes where machines are to be in areas where temperatures are high, then this one can be better compared to this one. So we have also another factor called the flash point. It is the lowest temperature at which an oil gives off sufficient vapor to support a momentary flash without actually setting fire to the oil when a flame is brought within 6 mm at the surface of the oil. So this is the lowest temperature at which an oil gives off sufficient vapor to support a momentary flash without actually setting fire to that oil. Then the fire point is the temperature at which an oil gives off sufficient vapor to burn it continuously when ignited. That is a factor or a property which one must consider when looking at lubricants. Then the pour point or the freezing point is the temperature at which an oil will cease to flow. Yeah. So when you use this particular oil, you realize that actually at a pour point or freezing point, where it ceases to flow, then you must identify that maybe this one is going to be not used in some points or in some places where there is always a variation in temperatures, high variation in temperatures. At points where you have freezing areas, for example in winter, then it means this oil is unable to flow, and therefore this point, the freezing point of this oil, is a point to consider. Thank you so much for watching. Follow us in our next lecture.